Hello everyone. In this video, I'd like to explain how to find a matrix for linear transformations on this example. So we know linear transformations are similar to the concept of functions where we take some input x and we get some output y. Well, linear transformations can be written in a way where matrix multiplication is on one side of the equation. So if we have linear transformation T, we take in an input vector V and we write it as matrix multiplication A times the same input vector V. So linear transformations take an input vector, let's say that's in Rn, or it has n rows, and outputs another vector, let's say that has m rows as well. So if our input has n rows, that means V has n rows. And following the rules of matrix multiplication, we know that this matrix has to have n columns. So the dimensions are m by n. So m by n matrix. So applying this concept to our example, we have in matrix A times our input vector -3, -1 equal to the output -19 and 10. When we know the dimensions of A have to be m by n, well, m and n are both 2 in this case. So I'm just going to write A as A, B, C, D. Now I'm going to do the same for the second equation. So if we do the multiplication, we get the following system. We get -3a minus 1b is equal to -19, and I'm just going to call this equation 1, and we do the same for the other rows. So -3c minus d is equal to 10, I'll call this 2, and for the other side as well, -2a minus b, this will be 3, and this will be 4. So if I put equations 1, 2, 3, and 4 into an augmented matrix, we have columns A, B, C, D, and it's an augmented matrix, so the right side contains everything on the right. -10 and 6. So this will be equation 1, and C's and D's are both 0 because we don't have C's or D's. Then equation 2, we have -3c, -1d, and the rest are zeros. Equation 3, and equation 4. So 0, 0. So if we row reduce this, we get the following. So this tells us that A is equal to 9, B is equal to -8, C is equal to -4, and D is equal to 2. So now that we know the values of the matrix A, if we put in an arbitrary vector into T, we can write it as the matrix A times this arbitrary vector. So T times an arbitrary vector, let's say xy, is equal to A, which we have, times the input vector. And if we do the multiplication, 9x minus 8y, and -4x plus 2y. So now we can put in any x and any y, and it will give us our output vector. So if we put in, let's say, v2, for example, x is -2 and y is -1, and we should get -10, 6. So let's see it. So we have 9 times -2 minus 8 times -1, and -4 times -2, plus 2 times negative 1. And we should get negative 10, 6. We should get negative 10, 6. 9 times negative 2 is negative 18, plus 8 is negative 10. And then here we have positive 8 plus negative 2, which is 6. And you can see that they do equal each other. So we put in any x and any y, and we have found the image of this linear transformation T. So I hope my explanation helped. So if you have any questions or suggestions, please feel free to leave them in the comments, and I'll see you in the next video.